This chart visualizes a documented reality. Between the 1970s and 2010s, Western male sperm counts plummeted by over 50%. The trend is global. The Institute for Health Metrics and Evaluation projects that by 2050, 3/4 of countries will fall below population replacement. For years, the scientific community scrambled to explain this decline, searching for a singular, isolated cause that could account for such a rapid drop-off. At this rate, we are approaching a critical threshold where we simply failed to replace our own numbers. The data points toward a biological breakdown that science is only beginning to understand. Historically, researchers studied environmental hazards in strict silos. The investigation separated into two distinct camps, those studying chemical pollution and those studying climate change. But a review led by researchers at Oregon State University evaluated 177 distinct scientific studies to see what happens when those variables are no longer treated as separate issues. The researchers pointed out a flaw in the siloed approach. Natural biological systems, whether human, animal, or invertebrates, do not encounter modern stressors neatly, one at a time. This suggests a new path for the investigation. The driver of the collapse may not be a single isolated threat, but the way multiple environmental pressures might be interacting in the real world. The first variable involves endocrine-disrupting chemicals, or EDCs. These are synthetic biological saboteurs, like PFAS and phthalates, that invade a cell and disrupt its reproductive functions by intercepting normal signals. These chemicals cause specific damage across the animal kingdom. Phthalates are linked to deformed sperm shapes in invertebrates, disruptions in rodents, and reduced sperm counts in humans. Because EDCs are used to manufacture everyday plastics and consumer goods, humans and animal populations are enduring constant, inescapable exposure. We have manufactured a chemical environment that actively attacks the reproductive systems of the creatures living inside it. The second variable is rapid environmental shifting, specifically through warming temperatures and lowered oxygen levels. This diagram shows environmental sex determination. For many reptiles and fish, normal temperature variations dictate a healthy, even split of male and female offspring. But extreme planetary heating pushes this trait out of bounds, derailing spermatogenesis and destroying the normal sex ratios of the population. A warming planet physically rewires the reproductive mechanics of life on Earth. So, what happens to an organism's fertility when you combine constant chemical exposure with severe heat stress at exactly the same time? This graphic illustrates an additive effect. Combined exposure to chemical runoff and severe heat creates a concentrated danger for wild birds. Because both cause abnormal sperm and infant mortality through entirely different biological pathways, they strike the same target from multiple angles. These combined threats multiply the damage, overwhelming an organism's ability to reproduce. This vulnerability is universally shared. From a microscopic invertebrate in a warming pond to humans living in a bustling metropolis, the combined stress of heat and chemicals damages reproduction across the entire biological tree of life. The scale of the crisis suggests we can no longer treat chemical regulation and climate change as separate, disconnected political issues. We have solved entrenched environmental hazards before. Through the Stockholm Convention, the global community successfully banded together to drastically reduce the worldwide use of toxic chemicals like DDT and PCBs. Even when massive chemical exposure was normalized in our daily environments, coordinated global intervention proved we could reverse the damage. The climate crisis and toxic chemical pollution are a unified assault on life's ability to reproduce. Securing our future requires fighting both fronts simultaneously.